And we're broadcasting. So we are going to go over summation notation. We're going to spend some specific time looking at this whole, what they sometimes call sigma notation. It's a short form for adding up a lot of numbers. And when we're dealing with data management, we're dealing with a lot of numbers. When we're demonstrating summation notation, we're not using very many numbers. So here we go. We've got daily sugar consumption, and we're using X to represent the number of grams of sugar that people eat. And we have a data table here, so we've surveyed 5 people, which is totally unscientific. And if we want to know what the total sugar consumption of those 5 people would be, in grade 11, I think we said, like, we used a big S to mean the sum of something, and every once in a while we would subscript it to say we want to know the sum of those 5 people. And then we would go like 102 plus 125 plus 88 plus 76 plus 130. Okay, so this is where we go. And instead of using an S, we use a Greek letter. And the Greek letter looks like this. And so this is, oh, guess what this is in Greek? Anybody? Yes, it's an S. Okay. Or it's called a sigma. So it's basically an S. Yep. So if you're in Athens and you're like riding on the bus and you see this, it means S. Okay. Now, this little thing down here is called an index, and it tells you what elements of the set you're going to be summing up. And so this says for the index 1 to 5, in other words, from item 1 to item 5, we are going to be summing up that variable X right there. So this is another way of symbolizing 102 plus 125 plus 88 plus 76 plus 130. Okay, so instead of writing that, I can write this to say I'm adding up the first 5 or these 5 values. So that's sigma. It's got indices to say which ones we're going to add up. I could change this a little bit if I wanted to use just a subset of the data. So I could say, oh, I want to go from the second observation, or sorry, let's go from the 3rd observation, so I don't have to write as many things, up to the 5th observation. Okay? So now that would mean, instead of doing all these, oh, I just erased them. I didn't have to. The 3rd observation, 88 plus 76, up to the 5th observation plus 130. Okay? So the index is handy. Now, when we're doing data management stuff, sometimes it's actually handy. If I'm just adding everything up in a set, if it's everything in this set that's being added up, I could index it like that, I equals 1 up to whatever n is. If it's everything, I'm just using a sigma. This means everything in the set. Okay? So this is the sum of all of the elements. Of a set. All right. Good so far? Internet land, any questions? Cat? Duck? Non-iconed person?
If I didn't, so if I use them all, I don't have to be adding.
That's right. Okay, so if you're just referring to the sum of the entire set, you don't have to put this index on. You just use the sigma, and you're good. Okay. We can actually use this same notation to denote even more things. Like we can include operations on each piece of data in the notation itself. Okay, so The average of all of this is 104.5. At least I hope it is. I just erased it. So the average of everything is 104.5. You'll see this a little bit later. X bar means average of the population. So the average of all of those is 104.5. I could ask for the sum of all the differences between each person's sugar consumption and the average. And I could write it like this. So I'm going to use the index even though I don't have to, because I'm going to use everything in this set. I'm going to take each individual observation and I'm going to subtract the average from it. And I'm going to square it. Believe it or not, we actually do this. It's to tell us how far away from the average all the observations are. And then I'm going to add up all those differences. Okay, so notice that there are operations happening before I sum up everything. Okay, we're going to do it to everything. So I'm going to write this out in long form just so it's fairly clear exactly what's happening here. So I'm going to start at the first observation, so I is equal to 1. So I'm going to do 102 minus 104.5. And I'm going to square that. Okay. Now I'm going to do it with every single observation. And if you know me, I'm not actually going to go through this whole ordeal of doing the calculation because I don't want everybody to get bored, including me. 130 minus 104.5 squared. Okay, so that's the interpretation of this notation. We're taking each piece of data, we're subtracting the average, we're squaring the result, and then we're adding them together through each piece of data. So that's a quick overview of summation notation. It's just a way of nicely encapsulating adding things up. And this is how we manage or express some of the operations that we do on big sets of data. Now this little expression that you see here, where we're actually taking each piece of data and we're subtracting the average and squaring it, this is how we get a measure of how far apart or widely distributed data is. If we didn't square it, we'd actually get a 0 because the differences would all ultimately add up to 0. So that's summation notation.